So yesterday we focused on translations, which was one of our rigid transformations. Today we're going to focus on reflections, which is our second rigid transformation. And remember, rigid transformations mean they don't change the size or shape of the image. Now, when I think of the word reflection, I think of a mirror image. I look in the mirror and I see me looking back at me. Some days it's a good look and some days it's not. But I still see me in the mirror. And I am identical. Me and my mirror image look the same. And when I say that, I mean like if I'm standing 5 feet away from the mirror, in the mirror it looks like I'm standing 5 feet away. And that's really, really important to think about because when we reflect an image, we're going to pay attention to where they say our mirror is. So we're going to start with this very first problem right here. It says graph the image of B, which is point 1, -1. Remember, we go X and then Y, after a reflection over the y-axis. Now, they highlighted it for you so you could see. This is the y-axis, the up and down axis. I want you to pretend that this is where your mirror is. And I want you to ask yourself, how far away is B from the mirror? B is 1 block away from the mirror. Now remember what I said. When I'm standing in the mirror, if I'm standing a foot away from the mirror, my reflection in the mirror looks like I'm standing a foot away because it's a perfect mirror image. So, if this dot is 1 away from the mirror, when it reflects over the y-axis, it's also going to be 1 block away. We'll look at another one. This one says, graph the image of M, 2, 8, after a reflection over the x-axis. Now remember, the x-axis is the axis that goes across. So I'm going to reflect this over the x-axis. So I'm going to ask myself, how far away am I standing from the mirror? Well, I'm standing 1, 2, 3, 4, 5, 6, 7, 8 feet away from the mirror, or 8 blocks away from the mirror. So if I'm 8 blocks away from the mirror on one side, then my mirror image is going to look like it's 8 blocks away. So here's my mirror, and here is my guy on the other side of the mirror. If I'm looking into the mirror and I'm 8 blocks away, then on the other side I'm also going to be 8 blocks away. Now, here's where it gets tricky. What do we do if it starts to ask us about reflecting images? That's a little harder than reflecting a point. But is it? Remember, a reflection is a rigid transformation. Rigid, meaning it does not change its size or its shape. So, I'm going to reflect this image the same way I reflected the points. I just have to do a few more points to make the image complete. So, I'm going to ask myself, how far away am I from the mirror? Now, our mirror is highlighted. It says graph the image of rectangle PQRS after a reflection over the y-axis, so our up and down axis. And remember, when we reflect over our up and down axis, the image moves across. When we reflect over our across axis, which is our x-axis, the image moves up and down. It's opposite. It's very tricky, but it's the opposite. So, let me start by saying, how far away are we from the mirror? So R is 1, 2, 3, 4 spaces away from the mirror. So if it reflects, it's going to reflect perfectly to the other side, and it's going to be 4 spaces away. Okay. Now, we're going to look at point Q. Point Q is 1, 2, 3, 4 spaces away from the mirror. So it's also going to reflect 4 spaces away. 1, 2, 3, 4. Now I'm going to move myself up here so that we can see this whole picture. Now I'm going to look at S. Here's S. How far is S from the mirror? 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 9 spaces away from the mirror, which means when it reflects, it's going to be 9 spaces away because it's a perfect mirror image. So I'm going to count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, here's the thing. If I plot this right here, then I kind of mess up my shape. That's not what I want to do. So I got to be very careful. So I'm going to fix this. I'm going to say this goes to here, this goes to here. And because it's a rectangle, that means my point P is already taken care of. Now I have reflected my image across the y-axis. We'll try one more. Okay. This one tells us graph the image of square TUVW after a reflection over the y-axis. But this time our mirror isn't highlighted, so we need to know where is our mirror. Now this tells us the y-axis. Remember, my y-axis is my up and down axis. This is my mirror, my up and down axis. So I'm going to ask myself, how far am I from my mirror? So I'm going to start with point W, and I'm going to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I'm going to count on the other side too, because if it's 10 away from the mirror, its reflection is going to be 10 away from the mirror. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now I'm going to look at point T. Point T is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 away from the mirror. So I'm going to do it on the other side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I'm going to look at point U. U is 1, 2, 3. So if it's a reflection, 1, 2, 3. And now I can complete my shape. So, in closing, remember, reflections are perfect mirror images. They are a flip, and in order to reflect something, you have to identify what you're reflecting over. I like to refer to it as a mirror because that's how I remember reflections, because I'm looking into a mirror.